Hi friends, welcome on board again. If you have some experiments in repairing electronic devices, you will confirm that detecting a failed capacitor could be tricky sometimes. So I decided to prepare this tutorial to show you how you can easily detect any failed capacitor using an LCR meter. So an LCR meter is a must-to-have a tool for any professional repair attempt. At least it saves a lot of time for you. And sometimes it's the only device that can tell if a capacitor is good or bad. However, you are not bounded to use this model, this brand, and this type of LCR meter. But whatever you choose, it must be able to measure the phase angle, dissipation factor, and ESR of the capacitor. Then the second, you should be able to change the frequency of your LCR meter. I will cover three types of capacitors because you will face with the failure of these capacitors more than any other type. The first one is these MLCC type capacitors. If the camera gets focused, yes. You will see these type of capacitors in many electronic devices such as cell phones or any compact device. I have covered this in the article because, as you know, many of my videos include an article. So I have explained everything regarding this type of capacitor in the article, and also many other important points that I don't mention in the video for the sake of time. And the second type is the electrolytic capacitors. The most problem comes from this type of capacitors. And the third is the polyester or MKT type of the capacitors. So as I said, I will not cover the MLCC in this video. So when you face with an electrolytic capacitor, the first thing you should see is the look. If the look was something like that, a bulgy top, chemical leakage, or change in the shape or size of the capacitor, then without any measurement or without any testing, this capacitor is failed. Just replace it. However, always it's not like the failure is not like this. So I will show you this capacitor. Nothing is bad by visual inspection, okay? Nothing is bad. This capacitor looks very good in shape. However, if I connect it to the LCR meter, if I connect it to the probes, you can see the capacitance is 13 microfarad, but this capacitor is rated as 22 microfarad and 400 volts. If you measured any electrolytic capacitor using an LCR meter and the capacitance was more than 20% off, I mean lower than its claimed capacitance, then replace that capacitor. For this case, 22 and 13 is a huge gap. So this capacitor is bad and it should be replaced. The next point is the frequency of the LCR meter. 100 Hz is the best frequency for electrolytic capacitors equal or higher than 10 microfarad. Why? Because the phase angle of these capacitors in this capacitance range is as close as possible to minus 90 degrees in this frequency. Also, the phase angle could be an indication of any failure. However, this is not the case with this capacitor. Minus 88 of phase angle is good. As a rule of thumb, any value higher than 80, or in the worst case, let's say 78, is a good value for phase angle. So the first check was shape and size, and the second check was the capacitance. For this capacitor, it failed by the second check, okay? It has the claim is 22, but it measures as 13 microfarad. So this capacitor is failed. However, this is not the case all of the time. And I should say I have faced with many failed capacitors that the capacitance is good. And let me show you another one that explains this claim. So this capacitor is also 22 microfarad, 400 volts. However, look at this. It shows the capacitance value is 19 microfarad. So this is very good. It's a very good capacitance for this capacitor. However, we go to the third test. So this capacitor passed the first and second test. No problem with the shape and size, no bulgy, no leakage. The capacitance is good, but look at the ESR. The ESR is very high. You can follow some tables, ESR tables, and you can look at those tables as a reference. Those ESR values are typical. However, some repair experience will show you or will prove you what ESR value is good and what value is bad. This ESR is definitely bad. If I show you the phase angle of this capacitor also dropped. However, is in the minus 83 is still okay. However, let me show you the dissipation factor. The dissipation factor of this capacitor is high. 0.1 is a high dissipation factor for an electrolytic capacitor of this for this value, okay, for this size and value. So that was the fourth indication, failure indication. First, size and shape. Second, capacitance. Third, ESI. Fourth, dissipation factor, and also the phase angle. Let me show you another capacitor. This one is 100 microfarad. Okay, sorry, the capacitance is 220 microfarad. Do you see that? For 220 microfarad, this capacitance is really good. 208 is a very good capacitance for this capacitor. However, look at the dissipation factor, is 0.4. And if I show you the ESR is 3.0. This is very high for this capacitance and this value. I think it should be lower than 1 or maybe lower than half O, in the milliohm range. Let me show you the phase angle. The phase angle is also out of range. Minus 67 is way below minus 80 in value. Okay, just keep 67 is in the positive value, I mean, is lower than 80. So this capacitance is definitely a bad capacitor. However, look at the capacitance. This tricks you. This is a trap for young players. 207 for 220. The difference is very low. The beginners think that this capacitor looks good. Another one. This one should be 10 microfarad, I believe. Yes, 10 microfarad. Look at this. It says 9.6 and the difference to 10 is very low. The capacitance is extremely good. The phase angle is okay, not bad. Look at the ESR. The ESR is just on the edge according to the tables, because I checked the online tables for the typical value of the ESR for this capacitor, 10 microfarad, 16 volts, and it says 16 ohm for this value for 10 microfarad, 16 volts. So 15 is on the edge. I will replace this capacitor definitely just because of the ESR, okay? But let me show you the dissipation factor. The dissipation factor of this capacitor is high, is around 0.1. Okay, this is another indication that this capacitor is bad. Or if you don't change this capacitor, Some people might disagree with me and say this capacitor is good. However, this capacitor will fail definitely in the next 6 months or 1 year. I will replace this capacitor. It's just on the edge. It plays on the edge. And now I want to show you this polyester or MCT type and show you something interesting with this capacitor. But I should change because this mode is for electrolytic. I should go to the capacitance mode, and yes, let me show you the ESR. What do you think with this capacitor? What is the initial value of this capacitor? Oh, one thing, the frequency. What is the initial value of this capacitor? The initial value is 470 nanofarad, but it reads as 200 nanofarad. However, the frequency is good or not? Let me show you the phase angle. The phase angle is -90. However, for this capacitor and with this range, this frequency is low. According to the manual of this LCR meter, this frequency is low for this capacitor. Let's put it on 10 kilohertz, and the phase angle is still 90 degrees, near minus 90 degrees, and the ESR is very good, 53 milliohm. This is milliohm, okay? Dissipation factor, very good. Look at the dissipation factor. This capacitor works, however, it lost more than 50% of its capacitance. I have replaced this capacitor. I found this capacitor in an inverter board of an LG refrigerator. Okay, it was before the rectifier stage, near the common mode choke for noise reduction, if you know what I mean, in the switching mode power supplies, just near the mains input, close to the common mode choke. This capacitor, as I said, first is the look. Sometimes this MCT capacitors or polyester type capacitors blow up, so that one is definitely a failure case. The second, as I told you, is the capacitance. This capacitor is bad just because of the capacitance. It has lost more than 50%. As I said, 20% is the margin, is the threshold. But look at this. ESR, phase angle, and dissipation factor for this capacitor is really good. So as you see, MCT or polyester might be a little bit different than electrolytic capacitor. If you found an electrolytic capacitor that has lost more than 50% of its value, definitely other parameters are also very bad. Definitely very bad. So as I told you, just follow the article link in the YouTube video description. I have explained many other things in the article, and this video is ended here. Don't forget to give me a big thumbs up and share this video with your friends. I hope this video will reduce your repair time and enhance your knowledge regarding capacitors in practice. I didn't follow any theory in this video. Catch you next time.